That way I know that we're recording. So thank you guys all for joining us. Like I mentioned before, this is the 5th webinar that we have in a series of 6 of them. So tomorrow night is the last one, and you can see here on the screen, it's miscellaneous topics that are found in their free response questions, and Tony Record at Avon High School is going to be presenting on that. Just like with these, it's going to start at 8 p.m. It's going to be a really good session because, those FRQs, this whole week and last week, we've been looking at FRQs by topics. We've looked at Riemann sum table problems. We've looked at differential equations. We've done some particle motion. We've also done F prime graphs. And tonight we're looking at rate in, rate out problems. Those are great sessions. But when you have these FRQs, a lot of times, there's always like that one part that just seems like it's a little bit out of left field. That weird part D or that weird part C. And it's kind of these miscellaneous topics that the College Board will spread around on different FRQs from year to year. And they trip up students, but getting those points, figuring out how to deal with those smaller topics that are in these bigger problems is extremely helpful. So we want to make sure that we get all those points as much as possible. So join us tomorrow from 8 to 9 and listen to Tony give a great webinar covering that. So without further ado, we are going to just jump right into the session tonight. Again, if you're just now joining us, if you could do a quick favor is when you type your name into Zoom, after your name, go ahead and put the initials of your high school. We have a lot of teachers that like to know if their students were on or not, and so it's easy to identify students if they have their initials afterwards. So Lebanon students, you can put LHS and so on and so forth. So keep an eye on the chat because we have a moderator tonight, Tony Record from Avon High School is going to be moderating, and if you have questions throughout the night, be sure to type those in the chat. I've talked to several of my students. I know Mr. Recker's talked to some of his students, and it seems like a lot of students are interested or learning about some more of this, but they're a little bit hesitant to ask questions, right? Don't be hesitant. Your AP exam is in 6 days, right? We have 6 days, so ask as many questions as you can. Feel free to ask questions. I promise you, if you're thinking of a question or you're wanting to know something, you're not the only one that's going to have that question. So there'll be other people that have the same question as you. So people will be happy to do that. So feel free to ask as many questions as you need, and I'll be happy to stop what we're doing to answer those questions. So, and Tony Record from Avon will answer a lot of those as well. So he can answer most of those probably. And if he feels like it's something that's important, we'll let him chime in and bring it to the whole group. Awesome. So we're going to go ahead and jump right into this because we got a lot to cover tonight. And the topic tonight, like I mentioned, is rate in and rate out problems. We pretty much see these every year. I used to call these the ugly equation problems because they typically are these problems that have kind of ugly equations. As we can see right here, this 10 plus 0.8 t times sine of t cubed over 100. It's not a very appealing looking question, but we don't have to fear because solving them is actually pretty straightforward and pretty easy once we get used to the kind of questions that they ask and what they're expecting on those questions. So we're going to see 3 of them tonight. We're going to see one from 2017, and we're going to see one from 2015, and then we're going to see one that's an AP style problem, but you haven't seen it on an AP exam yet. So I wanted to give you sort of a third oddball one, or not even an oddball one, but just a third one that I'm certain you probably haven't done yet in your classes because it hasn't been something that's on College Board's AP Central. So looking at the first problem, we're looking at 2017 AB number 2. So if you have your calculator, you probably want to have it out. You want to make sure that you're able to type these equations in, that you're able to perform the tasks that are needed on the calculator. So this question starts, and I'm going to go ahead and read it to you just so we're on the same page. It says, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display at a rate modeled by f of t. And f of t is given by the equation f of t equals 10 plus 0.8 t times sine of t cubed over 100, for 0 is less than t is less than or equal to 12. And f of t is measured in pounds per hour, and t is the number of hours after the store has opened. After the store has been open for 3 hours, store employees add bananas to the table at a rate modeled by g of t, where g of t is the equation g of t equals 3 plus 2.4 natural log of the quantity t squared plus 2t, for 3 is less than t is less than or equal to 12. In this case, it says G is measured also in pounds per hour, and T is the number of hours after the store has opened. That's a lot of information, right? When you read a question like this, it's really easy to get this information overload and kind of go into a panic. So one of the things that we want to work on tonight is learning how to distill all this information and really boil it down to what's important, right? What do we really want to know? And one of the things I recognize is we have something happening here, right? We have things being added and things being taken away. That's always a good sign that you're looking at a rate in, rate out problem. And one of the things that I have my students do, which I think has made us pretty successful on these problems, is as soon as we do this, we draw this little mini diagram to help us sort out the information. So I draw this circle sort of to represent the amount, or in this case, the bananas that we're starting with, right? And then we have bananas being added, and we also have bananas that are being removed. Inside of the circle, I always call this A of t. I call it A of t because it's easy to remember, and I can think of A as representing the amount of bananas. So this always gives me how many bananas I have, right? And then in the beginning, we have 50 pounds of bananas, right? We're starting with 50 pounds of bananas, so I'm gonna make my circle a little bit bigger, and I know that we have 50 to begin with. And I can see that right here. So whenever you're doing rate in, rate out problems, always pay really close attention to your starting amount, your initial value. There are some times where they don't give that to you directly, but it's kind of inferred in the problem. And there's also some times where the initial amount is 0. But on most of the problems, they have an initial amount, so be on the lookout for that. And then I want to figure out the rate coming in, and I want to figure out the rate coming out. Two things I want to point out that I think were a little bit trickier on this problem if you weren't paying attention is the first equation they gave us is the removal, right? That we're so used to the first problem being what you're adding as like your rate in, and we're used to the second problem be what you're removing, the rate out. But in this problem, they reversed it. They told us that they're removing bananas at this rate. So the rate in is actually G, and the rate out is actually F. They switched them around on us a little bit, and if you're not careful, a lot of students that they're reading got those mixed up, and it cost them several points on the test. The other thing that I want you to pay attention to is we kind of prime you the whole first semester of calculus that we say if you're talking about a derivative or a rate, we write that as F prime or G prime. That little prime symbol ends up being how we designate derivatives, right? Well, on these rate in, rate out problems, on a lot of them, you're not going to see a prime symbol. We just see F, right? But if you read the question carefully, it says they removed the bananas at a rate modeled by. So it's important to realize that this equation is the derivative. This is the rate already. So F is the rate out, and G is the rate in. So always pay really close attention to it. They name a function and call it a rate to realize that already is a derivative. Another dead giveaway is the units. Always pay attention to units. Notice it says that F of t is measured in pounds per hour. So next to F of t, I'm going to go ahead and write the units for that. And since we see this fraction, it's also another good indicator that this is a rate, pounds per hour. In case you're not familiar with that, LBS is how we abbreviate the word pounds in English. So, and then G of t, which is the rate in, is also measured in pounds per hour. And so this is also going to be in pounds per hour. So if we have this information, this is going to help us solve a lot of problems, I think. So let's go ahead and use this, and then we're going to jump into part A. So part A says how many pounds of bananas are removed. So as you answer these questions, always underline some of these key words. How many pounds are removed during the first 2 hours? So it's asking essentially for a total, right? Like what's the pounds, right? Look at the units. It's asking for pounds. And we know that F and G, those units are going to be pounds per hour, but they're asking a question about pounds, right? It's a total amount. So whenever you're given a rate and you're wanting to know a total, what we're going to end up doing is integrating at some point. And so here it even gives us the nice interval. It says during the first 2 hours. So if we want to figure out how many pounds of bananas are removed, we're going to integrate the rate out equation, the removal equation. So that's going to be the integral of f of t dt from 0 to 2. Notice I'm not including the initial amount of 50. And I know that a lot of students on the test ended up putting 50 plus because they're so used to adding that condition. But if you read the question carefully, it's only asking about how many that we removed. So it doesn't matter if there were 50 there to begin with or not. The removal process only involves f, right? F is the function that's being removing the bananas from the table. So we're going to get the integral of f of t from 0 to 2. Notice I did not write this big long equation down, and I would definitely recommend that you don't either, right? As soon as you get a problem like this, it's going to be really helpful to type these equations into your graphing calculator. And then once you type them into your calculator, just refer to them as f of t and g of t, because you don't want to accidentally write something down wrong. I can tell you if you write this down wrong and we see it on the exam, you're going to end up losing a point for what we call a copy error. So you don't want to risk that copy error. So now we can take this and we can type it into our calculator. So I'm going to switch over here to my graphing calculator. And in my y equals screen, I already went ahead and typed both of these functions into the calculator. You'll see a lot of equations on my screen right now because I kind of went ahead and preemptively typed in all the equations for tonight. And I did recognize one typo here. I'm going to go ahead and fix this right now. I forgot to put a plus sign between there. We would have had some really wacky answers if I didn't catch that. Perfect. So notice I have in my y1, I didn't put f in my y1, I put g, and I put f in my y2. And the reason why I did that was because I like to put the rate in first, and I like to put the rate out second, because I think about it as, in minus out, y1 minus y2. If you put f first and g second, that's totally fine, but you're going to have to kind of pay attention when I'm typing these buttons in that we might have different equations stored in different places. So this is my g of x, this is my f of x. And so to figure out the total amount that's been removed, we're going to hit math 9. We're going to integrate from 0 to 2. And then since I already have that equation stored, I don't have to type it in again. I can hit alpha and then trace. This F4 key is a nice shortcut to get my equations. And for my calculator, I'm going to do y2. That's where I have my rate out of dx. And my calculator comes up with a nice answer of 20.05117. So going back to our problem here, because we're allowed to use a graphing calculator, we don't have to do any of this by hand, right? We can just show the setup. It's important that you show them what you're doing, that we're integrating, and then we can go straight to our answer, which was 20.051175. I always recommend, writing down as many decimal places as you can. They will never penalize you for having more decimal places than you need. The only time we're going to penalize you is if you don't have enough, right? So we have to have at least 3 that are accurate, but writing down 4 or 5 or 6 is never going to hurt. You already have the numbers in front of you on the screen. It takes less than a half a second to write the extra numbers down. So just copy down what you see on your calculator, and then you're always going to be safe. So this is the first part right there, relatively straightforward if we kind of deconstruct the question. And now let's go to part B. Part B says find f prime of 7. So it's asking us to take the derivative of f. Remember, we already have an equation for f, right? I've got my f equation stored in my y2. And it wants us to differentiate it. Even though you're so used to taking derivatives, don't forget you have a calculator on this, so you don't have to take any derivatives or integrals by hand on the calculator section. I promise you they're going to test that on the non-calculator problems. On every single FRQ test, at some point when you don't have a calculator, they're going to make you integrate something with probably U substitution. And they're also going to make you differentiate something by hand because they want to know if you can do that. But on the calculator parts, we don't have to do it by hand. And a lot of times they give you equations that they don't want you to do it by hand because this gets too ugly too fast. So we can do this directly on our calculators. So if I go back to my calculator, and remember, we already have f, or I do. I have f stored in my y2. So now I just want to take a derivative. So I have math 8. That's a derivative. It's a shortcut. The derivative of, and we're going to type in y2 on mine. Again, if you typed yours in a different order than me, you might need to adjust what name you're calling it. And the x value that we're trying to find it at is 7. And I came up with negative 8.119539823. So we can just type that directly into our answers. So f prime of 7 is negative 8.119. It looks like it was 539. And like I said before, if you write at least 3, you're safe. But I would just keep writing because I've been surprised at how many students on the AP exam just stopped short and only did 2 numbers sometimes for absolutely no reason, and they lost an easy point. And then whenever you answer a question on the exam, we know there's like 4 parts on this question. There's A, B, C, and D, but sometimes within those parts, they also have multiple parts. They're like parts within parts. And so this is a good example of that. It says find f prime of 7. Sometimes you do that and you feel so excited you want to move on, but there's more to it, right? It says using correct units, explain the meaning of that f prime of 7 in context of the problem. So I can also pretty much guarantee you on the FRQs at some point, you're going to have to interpret a derivative, and you're probably going to have to interpret an integral on the test. And so it's really important that you know what we're looking for, right? There are certain things that are non-negotiable. So in this case, we found the derivative of f, right? So let me go back for a second and remind you what f was all about, right? Remember, f was the rate, it was a rate that bananas are being removed. And we just found the derivative of that. But remember, f is already a derivative. And whenever you take something's derivative, you're finding the rate of it. So essentially, we're finding the rate of a rate. So we just found the rate of f prime. And so one of the ways that we can write this, whenever you're trying to find the rate of a rate, is we can say f prime, which is, remember, f itself was the rate. The problem said that f is the rate. So the rate that bananas are being removed So think about what I just wrote real quick. What I just wrote is the rate that the bananas are being removed. All of that is literally just a long-winded way of saying F, right? F was the rate that bananas are being removed. So this is all representing F, and we just figured out that F's derivative is negative, which means the rate that they're being removed at t equals 7 hours is decreasing. Whenever something has a negative derivative, we know that that function is decreasing. So if f has a negative derivative like it does here, that means that f was decreasing, and f was the rate that bananas are being removed. So the rate that bananas are being removed at t equals 7 hours is decreasing. And then I'm going to say by 8.119,539, and I'm going to call this pounds per hour squared. And think about a couple things. First of all, I use the word decreasing here. And because I use the word decreasing, I didn't want to put this as a negative number. If you put the word decreasing and then you also put a negative number here, you've essentially done like a double negative. You're saying it's decreasing negatively. Those two things kind of cancel out and you end up not saying what you want. So if something is decreasing, don't include the negative in your explanation. Second of all, look at the units, right? You have to get these units correctly. And the units, remember, of F, when we wrote those down to begin with, we said that the units for F were in pounds per hour. And so if we take F's derivative, every time we take a derivative, we're essentially dividing by another denominator. So instead of being pounds per hour, it becomes pounds per hour squared. So this is our explanation. A couple things that you have to have in your explanation. Number one, whenever you're explaining or interpreting a derivative, you have to basically describe that it's a rate, right? Get used to saying the word rate to interpret derivatives. Number two, it's really important that you give the time, and it's at t=7. When you're interpreting derivatives, remember it's instantaneous. Derivatives are instantaneous rates of change. And so we have to be very clear that what we found was only for a moment. So when we use the word at, that clearly indicates it's at that moment and no other time. So if you say during the 7th hour or after 7 hours or over the hour or something of that effect, you're no longer doing something instantaneous. You're now basically giving it a duration. So we want to be careful for that. And then you also want to make sure you always have the units. Students forget the units a lot, and you can't get the explanation point without having the proper units. So these are the things that we're looking for. Before we go on to part C, I want to show you the scoring of part A and B so you can see where our points are coming from. So in part A, it says you got 1 point for the integrand. The integrand is this R of t. So basically it means if you knew to integrate, it would probably be helpful if I was on the right year, wouldn't it? You probably wonder what the heck is R of t. This is the one that we're looking at. You get 1 point for the integral in this case. And the integral means you had to have known to integrate f, and you had to have had 0 to 2. Whenever it says integral, an integral has two parts. It has the argument, which is the integrand. That's the function you're integrating. And it has limits 0 to 2. So if you had all of that, you got the first point. And then for having the correct answer, you would have had a second point. So 2 points for part A. This little piece down here, the sentence, was not necessary. The College Board likes to just always interpret their answers, but it didn't ask you to do that. So this first line that we're looking at would have gotten both of those points absolutely. And then in part B, here we have f prime of 7, that's what we found, was negative 8.120 or negative 8.119. You could have rounded our answer or not rounded it. Either one of those was fine, and that gave you the first point. And then the explanation, which theirs is a little bit different than mine, but they both get full points, obviously. After the store has been open for 7 hours, notice the word the rate that bananas are being removed is decreasing by 8.120 or 8.119, depending on how you wrote it, pounds per hour per hour. And pounds per hour means pounds per hour squared. So this is the second point. So we're up to 4 points so far. I definitely would argue that the first part A, we could easily get those 2 points by reading the question. And in part B, we definitely should have gotten that first point of getting that calculation. I know that students have a lot of difficulties sometimes with the interpretations, but there's a lot of resources out there and a lot of practice. Definitely spend some time practicing and remembering that we have to use the word rate, and then we have to give the units, and we have to give time. If we have those things, then we can get our correct interpretation. But this one is a little bit tricky, and a lot of students, in all honesty, do not end up earning that point on the AP exam. It's probably the most missed part of this question when I scored it. So let's go on to part C and part D. And I kind of reiterated the problem here. And then part D says, is the number of pounds of bananas on the display table increasing or decreasing at time t = 5? And then give a reason for your answer. So here's what I'm going to do. This is what I have my students do. And I usually do it in the very beginning of the problem. But remember, we had this little circle and we said, this circle is the amount of bananas. And we know it started with 50. And we had a rate coming in that was called G. And we had a rate going out, which was called F. And so what I like to do, because we know we're going to have to use it, whenever you have a rate in, rate out problem, you're going to need this at least once and usually twice in the problem. I like to write an equation just for A of t. Remember, A of t represents the amount of bananas. It's not a rate, it's a total amount of bananas. And we know from the fundamental theorem, the amount, and if you watch the F prime webinar or even the particle motion webinar, we did very similar problems, but just in different contexts. The amount of something is equal to the starting amount, which in this case is 50, plus the integral of the rate in, and the rate in, we call that G, right? It's the integral of G of t dt. And I'm going to leave this top blank for a second, minus the integral of the rate out. And I purposely left something incorrect on here, and I wanted to see if you would catch it. And so first of all, the top limits here are going to be our ending time, right? And so the top limit of your integral always has to match whatever time you're trying to find. So if you wanted to find A of 2, you would plug a 2 up here. If you wanted to find A of 7, you would plug a 7 up here, right? Well, in this case, we're not plugging in any time. It's really helpful just to write what I call a generic equation. Just get a formula for A of t at no particular time. And so in that case, the top here is going to become t, because it's going to match A of t. If I'm not going to plug a number in here, I'm not going to plug a number in here. But can you see the mistake that I've made? And I'm going to pause for a minute, because that way if you're watching, I want you to jump into the chat feature and see if you can figure out what the big mistake is or what the error is with what I have written right now. I promise you I can wait you out. So somebody out there has to notice sort of a gaffe here. We got a couple of you that are chiming in, which is great. So one person absolutely wrote that I wrote 50 instead of A of 0. And that's a good catch because in my classes, I always make my students write A of 0 here first. And I have them write A of 0 here because then it reminds them that's going to be the bottom limit, right? It helps you know what the bottom limit is. And then we cross it off and put 50. So that was definitely kind of an issue here. But there was a bigger issue, and several of you are starting to notice this already. And this is great. So here's what you have said. You said the bottom limit is when we start, right? And if we look really carefully on this problem, this was a big issue on this test. It says F of t, which is the rate out, it starts at 0. It starts right away. People are removing bananas immediately. But G of t, which is the rate in, it doesn't start until 3 hours after the store is open, right? It doesn't start until 3. So our bottom limit for our rate in shouldn't be 0. It should be 3, right? And this caused a lot of problems because students were so used to just writing these two integrals as one big integral, and it forced them to separate them. That your amount is going to be your starting amount plus the integral of the rate in from when you start to when you stop, minus the integral of the rate out from when you start to when you stop. But in this case, the starting times aren't the same. And a bunch of students didn't catch that, and it cost them some points down the road. So our amount is actually equivalent to this. Now, why do I want to write this? Because there's a couple of things that this is going to help us with, and you're going to see it here. And the more practice you get just writing this down right away, the easier these problems are going to be to solve. Because part C says, is the number of pounds of bananas on the display table, right? If you look at that phrase, that's just a long-winded way of saying A of t, right? Remember how we said A of t is the amount of bananas on the table, right? So the question is A of t increasing or decreasing? So all this wordy question is asking one simple thing. Is A increasing or is A decreasing? Well, the way that we can always check if a function is increasing or decreasing is to take its derivative. And if its derivative is positive, we know it's increasing. And if its derivative is negative, we know it is decreasing. So now that we have an equation for A, we can really easily now differentiate it. So let's find A prime. So A prime of t, well, we differentiated the left and got A prime. 50's derivative is obviously going to be 0. And then here, if we differentiate this is that second fundamental theorem of calculus. We spent some time on this in the webinar on F prime graphs yesterday. So if you weren't here for that and you're a little bit confused on these kind of problems, you might want to jump on that webinar and watch it. But to differentiate an integral, the second fundamental theorem says we can simply plug in our variable. So we're going to get g of t. And then we multiply that by the derivative of the variable, which is just 1 in this case, minus, and then if I differentiate this, same exact second fundamental theorem, f of t. So A prime of t is just going to be g of t minus f of t. Now, if you're at a different school besides Lebanon, you may have got to that equation on your own doing it a different way, and that's totally fine. If you just knew that g minus f is what we're looking for. And then we want to know what's happening at the particular time t equals 5. So I want to know what is A prime of 5? Well, A prime of 5 is going to be g of 5 minus f of 5. And going back to our calculators, I can compute that. Remember, we've got, in my calculator, I've got g of 5 stored in y1. So if I go to y1 and I want to plug in 5, I can just use parentheses like function notation, y1 of 5, minus, I want to do f of 5. So I'm going to go back to y2 of 5. And then I get, in this case, negative 2.263103. And so I can write that down on my screen. And so I get A prime of 5 equals negative 2.263103. And we just said that we knew that A would be increasing if A prime was positive, and A would be decreasing if A prime was negative. So since we have A prime is negative, we know that the answer should be decreasing. And there's a lot of ways you could give a reason. We could simply just say, in this case, A prime is less than 0. You could have said g of 5 minus f of 5 is less than 0. That's the same thing. Or you could have said, if you wanted to, g of 5 is less than f of 5. Essentially what you're saying is the rate in is less than the rate out. So if you're removing things faster than you're adding them, then the amount is obviously going to be decreasing. So there's a lot of ways that you can interpret that, or that you can give a reason for that. If you learned it a specific way in your classroom, I'm sure that if it's one of those 3 ways, those would all be accepted. So let's move on now to part D. And you're going to see now again why it's so important to write an equation for A, because it says in part D, how many pounds of bananas are there at t equals 8? Well, we already have a formula for the amount of bananas, right? We already said the amount of bananas at any time is just this. And so the amount at time 8, since we're trying to find the amount, notice the key word here says pounds, right? Pounds is a total, it's not a rate, so that's why we're using A of t, is equal to 50, the starting amount, plus the integral from 3 to 8. Now we're plugging in 8 for t. And notice the rate in, we have to start at 3 and not 0, minus the integral from 0 to 8 of f of t dt. And if we type all of that into our calculators, we're going to get 50 plus math 9 to integrate from 3 to 8. And Tony, if you're on here in the chat, could you give the kids a reminder how to do integration on the TI Inspire. So if you're using the Inspire, Mr. Record is like the guru of all gurus on that. So he'll put that in the chat if maybe you're not 100% sure how to do that. And we're going to do of Y2, that was our rate in, dx. And then, oops, I should have been Y1, right? I put my rate in Y1. I better be careful now. I'm going to make this Y1. My rate in was Y1. And then we're going to do minus math 9 again. But in this case, we're going from 0 to 8 of Y2. And in this case, we can hit enter. And my calculator came up with 23.347 395 something, something, something. So going back here, we get 23.347 395. And there's our answer. Let's take a look at the scoring guide for that problem. We've looked at A and B already, but looking at C and D, in part C, just for knowing to check F of 5 and G of 5, you're going to get a point. What they're trying to avoid is that you're not finding F prime and G prime. Remember, the problem said, is the amount increasing or decreasing? And here's what happens. Students see that word increasing or decreasing, and you've been so trained that when you hear that word that you should take a derivative, right? It's a derivative question. But then what you might have forgotten was that F and G are already derivatives. They're already rates. And so we don't have to differentiate it again because that already is the derivative. And so this is a case where even though it said increasing or decreasing, we weren't trying to take G prime and F prime. It was just G of 5 and F of 5. And then the answer with reason, I showed you several different ways you could have written that. Any one of those would have been acceptable. And then in part D, notice 2 points for the integrals because they were different integrals, right? One of them started at 3 and one of them started at 0. And so if you had both of those separate with the right limits on them, you would have gotten 2 points just for that. And then 1 point for the final answer of 23.347396 or 23.347 if you rounded it to 3 decimal places. If you had combined these into one integral and you said 0 to 8 because you weren't thinking about it, you would have gotten one of those 2 points because you would have had one of them right technically, but then your answer would have been wrong, so you would have gotten a 1 out of 3. So I don't think anything in that problem was particularly overly difficult, but if you haven't done many of them, sometimes they seem like they're really unattainable, but they're very, very similar in nature, all of these problems are. And so the more that you do, the better that you're going to get at them. And there's pretty much one every year. So spend some time definitely between now and the Tuesday's exam, spend some time trying some of those rate in, rate out problems and practicing a little bit, right? The average on this problem was not as high as you might think. It was 4.01. So it was barely more than 4, but pretty much exactly 4 points. So anytime that we can beat the average, we know that we're doing a good job. If we can get 7 or 8 points on a problem like this, you know you're crushing it and you're well on your way to a 5. So I'm going to jump ahead here. So if you have the packet that you downloaded or you have it, I'm jumping to the third problem. I'm skipping the second problem. And so if you don't have the packet, you can ask your teacher for it and they can send it to you or print it off for you. And you can go back and try the second problem. The second problem is from 2015. It's another good practice one. But I want to end our session tonight on an AP style problem that is not from an actual AP exam. So if you're not from Lebanon, I know you probably haven't seen this problem. So it's something that you're going to have to think about if you've done a lot of rate in, rate out problems already. So this is also a calculator active problem. And it says a large tank contains 40 gallons of water at time 0. And then during the interval 0 to 2 hours, water is being poured into the tank at this rate, W of T. But then during the same time, there's a leak, right? And so water is being drained out, and the rate that it's being leaked out is L of T, which is this function right here. Notice both of those are in gallons per hour. So just like we did last time, I'm going to start by kind of drawing this circle. I'm going to call this A of t like I did last time. A of t always represents the amount. It's not a rate, it's a total. And I like to write the starting amount so I don't forget it, right? So in the beginning, the starting amount was 40. And then we have two things happening, right? We're adding to this pool, and we're adding it at a rate of W. And then we're also leaking, so there's a rate out, and the rate that it's leaving is L of t. And remember, W is in gallons per hour, and L of t is also in gallons per hour. This is another example where they've given us functions, but they didn't use any prime symbols, but yet they're still rates, right? They're still derivatives. So always look for those keywords. If something is a rate, you know it's already the derivative. And so part A says, how much water has been poured into the tank? Notice it's not asking for a rate, it's asking for a total, right? How much total water? If you can add that word total in front of the noun and it still makes sense, then you know it's like a total, it's an integral, right? To add things up, we total them and we integrate to add in calculus. So we want to figure out the total that's been poured into the tank. So notice again, I don't care about L. L is what's leaving the tank. And I don't care about this 40. The 40 is what was already there to begin with, right? It wasn't poured in, it was just there. And so if we're talking about things being poured into the tank, that's only involving the rate in. So we're going to integrate W of t dt, and it says after 2 hours. So we started at time 0, and we're stopping 2 hours later. And now we can just type this into our calculators. And if we look at my calculator, here's my y equals screen. I already have this W of t on my calculator because I kind of did this preemptively. I've got W of t stored here in my Y5 screen, and I've got my L of t stored here in my Y6 screen. So you're going to see me use Y5 and Y6, but obviously if you're typing it in your calculator, you're going to have probably stored in maybe a different one. So don't be confused by that. One of the things that I would definitely strongly recommend is as soon as you get one of these problems on the exam, type the equations into your calculator. You don't want to keep typing them from scratch every time you're trying to do a calculation. Put them in your Y1 and Y2 because you're probably going to use those 3 or 4 times during the problem. And so type them in and then double check, right? This is a one-time exam to determine whether you get credit for a year's worth of work. And so the most disastrous thing that could happen is typing it in and then not realizing you had a typo. And so double check, triple check before you go forward. Take that extra 5 seconds just to make sure everything's exactly right. Make sure the decimal points are correct, that the negative signs are correct, that there's no mistakes. So based off of this, I am now trying to integrate from 0 to 2 of, on my case, remember I had mine in Y5. So I'm going to go to alpha F4. That's the shortcut for the TI-84. And then I'm going to hit Y5 of dx. And my calculator gives me a grand total of 3.63155. So for my part in part A, that's approximately 3.63155. Just like with the last problem, essentially, this is going to be worth 2 points. 1 point for the setup for showing that we're integrating from 0 to 2 of W, and then 1 point for the answer. So that would be worth 2 points. So let's now look at part B. And now we have this new question that says, find the time t between 0 and 2 hours when the amount of water is a minimum. So a lot of times on these rate in, rate out problems, they're asking for minimums and maximums. Notice it didn't say any kind of description. It didn't say relative. It didn't say absolute. If it doesn't give you a description, we know that it's talking about an absolute minimum. So if it just says find the minimum, it's going to be the absolute minimum. Or if it says find the maximum, it's going to be the absolute maximum. When you're doing these story problems especially, you know they're always going to be absolutes. So let's take a look at how we're going to set this up. Well, remember the last time that we did this, we had to write the formula for the amount of water, right? So we said that A of t is the amount, right? So let's write an equation for A of t like we did last time. So we said the amount of water at time t is always equal to the amount in the beginning, right? A of 0, plus the integral that the rate in from 0 to t. You have to get comfortable of putting a t up here, right? A lot of students want to instinctively put a 2 there because they see this 2 in the problem. But let's go ahead and put a t up there because I'm not giving it a time. We're trying to make a formula for any given time. And so when you're writing an equation using the fundamental theorem, whatever time you're trying to find, whatever's here is going to match the variable up here. So if I want to find A of t, I'm going to have a t up here. And the number time that you're using in your initial condition is going to match this right here, right? So A of t is going to be equal to A of 0 from plus the integral from 0 to t of w of t dt minus the rate out, so 0 to t of L of t dt. This is our general formula. And then I always like to put A of 0 here first because it helps me remind me that I'm putting a 0 here. Be careful because sometimes they don't give you the amount at time 0. If they had given us the amount at time 1, our starting amount would have been from A of 1, and then our lower limit would have been a 1. And then what was A of 0 in the problem? Remember, A of 0, if we look back up, the starting amount was 40, right? So this is going to be a 40 here. So really our amount at time t is going to be 40 plus the integral from 0 to t of w of t dt minus the integral from 0 to t of L of t dt. Maybe you put these two as one integral and that would be totally fine. I like to separate the rate in from the rate out. And the reason why is because of that banana problem on 2017. So after that problem, I've always just separated these two things as separate problems. So here, we're trying to figure out when the amount of water is a minimum. Well, think about how you find a minimum. We talked about this before, but the way you find a minimum of any function is you set its derivative, a prime of t, equal to 0 first, right? To find anything's minimum, we say a prime has to be 0. So let's find a prime, just like we did last time. A prime of t is going to be equal to the derivative of all of this. Well, 40's derivative obviously is 0. The derivative of this, we're integrating and then taking a derivative. That's just w of t. And the derivative of this is just going to be L of t, right? And we're trying to set this equal to 0. So if we're trying to find a relative minimum or relative maximum, the first step is set the derivative of A equal to 0. Well, A's derivative is just W minus L, and that means that W of t is going to equal L of t, right? So you're always going to find your minimums and maximums when your rate in function is equal to your rate out functions. Some of you might have just known that from the beginning, that when you have your equation, you can just set rate in equal to rate out, and that's going to be your critical point. And that's totally fine to do that. But this is why that's true. So if we go back to our calculators, notice I've got my rate in as y5, and I've got my rate out as y6. So I'm going to unhighlight these other functions real quick. So I'm not going to need y1, y2, y3, or y4. But I want to figure out when y5 equals y6. And before I graph those two, always change your window to match the time window, right? Time was between 0 and 2. So my x window is going to be between 0 and 2. And then I'm not really sure what my y window should be because it's hard to know. So I'm just going to put it from -5 to 5 and see what happens. So if I hit graph, and I went from 0 to 2 for x, right, because time was 0 to 2, and I just go ahead and graph this, we see the first function is there. The second function is here, and we can see this point of intersection right here. And so I want to find this point right here. This is where my rate in equals my rate out. So to find that point of intersection, we can do second calculate intersect. That's the 5th choice down. It's right above this trace key, right? Second calculate is how, if you ever have a graph on a TI-84 and you want to know a particular point, like, hey, what's this point right here on the graph? That second calculate button is how we're going to get that. And it says, what's the first curve that you want? Well, if you only have 2 graphs drawn, which is probably the best thing to do, then you don't have to worry about this because the cursor is already on the first curve. Just hit enter. And notice it jumps to the other curve. It says, is this the second curve? Well, of course it is. We only have 2 of them. And then you hit enter. Then it says guess, meaning you could type in a guess if you can tell, like, oh, it's about 1.5 or something, but just hit enter on this. And after it says guess, if you enter a 3rd time, it will automatically jump and then jump to that point right there. And that point is x equals 1.58025. So this is sort of our critical point of where those 2 graphs intersect. So I'm going to do something really quickly, because when you find a point on the calculator on a TI-84, once you go back to your main screen, that point is still saved in your calculator. It automatically saves that x value into x. So if I hit x right now on my screen and hit enter, look what comes up. That was the point we just found. So as long as you don't move that cursor, it stores that x value into the x menu for you. You definitely don't want to keep it there, because if you find a different point, or if you move the cursor, it's going to change it. And you might want to use and find another point later on. But if you're doing area volume problems, especially, this is a really helpful thing if you need more than 1 point of intersection. So what I'm going to do is I want to keep that number, and I want to store it in my calculator so I don't have to keep retyping it. So what I'm going to do is I'm going to take that x value, which we just said it was this, and I'm going to hit this STO button that's above the on sign. It says STO. And when you do that, it says take that number that's there and put it somewhere. And I'm going to put it under this green A key. So I'm going to hit alpha, and then right below it, the math button has a green A, and hit enter. And then what that did was it took this number, and now it's forever stored in the space of A. The reason why I did that is because if we go back to our problem, I know that my A value, what I just found, is going to be equal to, and it was 1.580825. What that's going to do is make my life easier a couple of ways. One, on my calculator, I can always just call it A and it'll come up. And B, when we're writing our calculations, we don't have to write that long decimal point down every time. We can just call it A from here on out, as long as I declare it as A. And so now I'm going to make my little table. And I have my time here, and I have my amount here. And when you're doing an absolute minimum, remember the goal is you have to include, to find an absolute minimum, a table of values with the endpoints. Our endpoints were 0 and 2, as well as any critical values. And the only critical value that we found was 1.580825, right? So I'm going to call that A. I don't have to write that whole decimal point down. And then we plug all of these values, 0, A, and 2, we plug them back into the original equation to figure out what they are. Well, don't plug 0 in, because we already know the amount at 0, right? The amount at 0 was 40. So really all we have to do is calculate the amount at time A, the 1.58, and at time 2, and see what we get. This is another reason why it's so important to have that equation for A written down, because we're going to have to plug things into that when you're finding minimums and maximums. So let's go ahead and go to our calculators. And to figure out what the amount was at time A, we said the amount is equal to 40, my starting amount, plus the integral from 0 to A, right? So I can just say alpha A. I don't have to write that long decimal down. And we called this, I believe, Y5 was my rate in. So I'm going to go down to Y5. That's my rate in. And then we're going to subtract math 9, the integral from 0 to A again of the rate out. In this case, that was Y6. So if we go down to Y6, right here, this gives me a grand total of 33.425. So I'm going to go back to my screen and I'm going to type that number down in my table. So right here, it was 33.424506. And now all I have to do is find the amount at time 2, right? And the beautiful part about the calculators on the TI-84s, and I'm sure the Inspires are the same way, is you don't have to type all that over again. You've already got it written up here. All we have to do is go back up and highlight that equation we just used and hit enter, and it brings it right back. So we don't have to retype it. All I really need to do is go up there and change these upper limits to 2, because if I want to figure out the amount at time 2, I need to change those. So this is at time 2 instead of A. And at time 2, I get 35.1848313. So filling out my table here, my last value here is 35.184,838. So now I have my table, I can actually answer the question. The question was, find the time t when the amount of water is a minimum. Yesterday's webinar on F prime graphs, I told you whenever a question asked me for the absolute minimum or the absolute maximum, I always answer it the same way. I always just get in the habit of saying the minimum, no matter what it asks for. I say the minimum is or equals 33.424506. That's the minimum. And I always say at time t equals whatever the time was. Well, remember, since I already said A was 1.58, I don't have to write that whole decimal. I can clearly just say at t equals A. As long as you define the variable and you use it consistently, you can refer back to it. If that makes you uncomfortable, you could say at time t equals 1.580825. That's fine as well. So I like to put that little statement there, because if it asks for the minimum, I've got the minimum. If it asks for the time, I've got the time. In this case, it only wanted the time, so you could have just said at time t equals A if you wanted to, but I like to put both because they go back and forth between what they ask for, and getting in the habit of saying this, you know that you're safe no matter what they ask. So I want to take a look, and I know we're right at 9 o'clock, but I want to take a look at this next part of this just briefly to show you kind of how this relates to what we've done. These will be pretty quick, right? And so it says, is the amount of water, remember the amount of water, we already called that A, right? The amount of water is A. Is that increasing or decreasing? Well, that looks a lot like that problem we just saw, right? That if you want to know if something is increasing or decreasing, you want to know about its derivative, right? If something has a positive derivative, then it's increasing. If something has a negative derivative, then it's decreasing. And so if I want to know if the amount of water, A, is increasing or decreasing, I just have to find A prime. Well, we already found A prime on the previous part, right? We already said that A prime is just W minus L. So once again, even though it uses words like increasing or decreasing, we're not trying to take the derivative of W and L because they're already rates, right? This is already the derivative for the amount. And so all I have to do to figure out if the amount is increasing or decreasing at 1 is figure out if A prime of 1 is positive or negative. And A prime of 1 is simply W of 1 minus L of 1. And since we already have those stored into our calculators, W of 1 is just going to be Y5, right? That was our W. That's our rate in at 1 minus L of 1. And L of 1 is just Y6 of 1. And this gives me negative 3.989. And so just like with the last example that we saw, we have a negative rate. So A prime of 1 is negative 3.9890534, or 314, I believe. And since A prime of 1 is negative, we know that the amount is decreasing. And for our explanation, there's a lot of ways we could say it. We could say it because A prime of 1 is less than 0. By the way, I can say this because I already defined what A prime is, right? I said very clearly that A prime is W minus T. You also could have said because W of 1 minus L of 1 is less than 0. Or you could have said because W of 1 is less than L of 1. All of those are synonymous with each other, and they would all receive the credit. And then I want to show you this last part because this kind of goes in line with what Tony is going to talk about tomorrow a little bit. It's kind of those weird oddball part D questions sometimes. And so this says the tank holds up to 300 gallons of water. And it says for time greater than 2, water continues to be poured into the tank at a rate of W of T. So the rate in is not changing. But it says water is leaking out at a constant rate of 1.02. So what has changed is the rate out. So starting at time 2, our rate out is now different. Set up, but do not evaluate. So just set something up. An equation, that's important, involving one or more integrals. There should be an integral in our problem that can be used to find the time W when the tank first becomes full. So there's a lot going on here, but here's what I hear. I want to know when the tank becomes full. Well, the tank can hold 300 gallons, right? And the amount of water in the tank, we already said was A of T. So really, all of this comes down to saying the amount in the tank is equal to 300. That's kind of what it's asking for, right? Well, don't we have a formula for A of T essentially? We had this formula that we wrote on the previous page, right? We said A of T is equal to 40 plus the integral of W from 0 to T minus the integral of L of T from 0 to T. We can't quite use this exactly the way it is because that formula worked between 0 and 2. And now we're looking at what happens after 2. And so we're going to kind of have a new amount equation. So the amount at time T is going to be equal to a starting amount, but we're starting at time 2 now, right? Because we're doing this after time 2. So the amount at time T is going to be how much there was at time 2. That was the beginning now, plus the integral. Remember, we have to have a 2 down here on the bottom because this has to always match of W of T dt minus the rate out starting at 2 of L of T. And the problem with this L of T is, remember how we said in the very beginning, L of T was defined, right? L of T was that long equation we had, but after 2, the rate in is still W, so that was fine, but the rate out is no longer L of T. The rate out, it said, was not L of T, but it was a constant rate of 1.02. So the rate out is going to be just 1.02 dt. That's the trick to this problem, was they changed the rate out. We have our amount and the rate in is still going to be W, but the rate out is no longer L, it's 1.02. And so our equation is not going to involve L, it's only going to involve 1.02. Then it says at what time W. Remember, the time is always what goes on top. And so all they're asking you to do here is replace that T with a W. That this is the time that we're looking for, right? So we want to know, this is our equation for the amount at time T. And we want to know, when does this equation equal 300? Well, we have to also know what A of 2 is. And that's what we found on the previous page, right? So one of the things the AP exam does a lot is you'll find something on one of the problems, and then you'll use that later on. So we figured out that the amount at time 2 was 35.184. And so in this case, we can finish our equation by saying the amount at time 2 was 35.184838. That was the amount at time 2, plus the integral from 2 to W of the rate in minus the integral from 2 to W of the rate out, which was now 1.02. This would give us a nice expression for how much water is in the tank. And we said in the beginning, we want to know when that is going to be equal to 300. So this is the equation that we're looking for. There's a couple of other ways that you may have written that. This is kind of the most direct way, is to say we're starting after 2. So I'm going to start with the amount at 2 and then add the amount I've added since 2, and then take away the amount I am withdrawing or leaking after 2, and set that equal to 300. Notice it says set up, but do not evaluate, meaning you're not going to do anything with this, right? You're just going to leave this like this and end up, stopping right there. So that is the end of this webinar. Rate in, rate out problems, a huge part of the AP exam. You pretty much know for sure there's going to be an FRQ on them. Spend as much time as you can practicing them. If you have any questions, Tony and I will stay on. You're welcome to type questions in the chat. You're welcome to unmute yourself if you want to ask questions. If it's hard to type it in. You're welcome to ask questions about any of the problems that we did tonight. You're welcome to ask questions about rate in, rate out in general. You're also welcome to ask questions just about things that you've been working on. Like, hey, I've been doing this, in class and I'm struggling with it. Can you help me clarify this, or something like that? And then don't forget, tomorrow at 8 o'clock Eastern is the last live webinar. Tony Recker is going to be looking at miscellaneous topics. So make sure that you're on for that. It's really, really, really going to be amazing. And so hop onto that. I'll be moderating it. It'll be a great thing. And it's going to give you a lot more points. So every time you watch one of these webinars, try to get 1 or 2 points better, right? If you can pick up 1 or 2 things, you're going to be able to get that score up. So you guys have been awesome. And I'm looking forward to hearing what Tony has to say tomorrow. And Tony has already made a promise. It's going to be as good as Avengers Endgame. Luckily, the bar is low. Hashtag unpopular opinion. Not a great movie, but this will be much better. And I promise you it won't take 3 hours to get to the main point. So good night to those of you that were needing to log off. And like I said, you're welcome to stay on if you want to ask any questions or just talk awesome math stuff. So have a great night, everybody, and we'll see you tomorrow night.